All right, here we're asked to see if this series is convergent or divergent. It's natural log n over n. Well, this one looks like maybe we could compare this series to just 1 over n, the harmonic series, because it's very similar except for that natural log of n on top. So what do we know about 1 over n? That's the harmonic series. Put some room here. This is the harmonic series, which we know is divergent, is a divergent series as we've seen before. So what we want to look at is if we can show that this series over here is bigger, then that one would also be divergent. So is that series always going to be greater than or equal to 1 over n? I think so, yeah. If you put anything in that numerator, no matter what that positive n value is, having something bigger in the numerator than 1 on this side should make that fraction bigger. And so what we can say on this one is this series over here is going to be divergent by comparison to harmonic series. So that is how we would describe this one. So this is a divergent series. All right. Let's have you guys attempt one here. See if you can state whether you think this series converges or diverges. So pause the video and try it out. All right, let's see what you had here. This series that we're looking at is going to be very close to, we need to keep the 5 involved. We also need to keep the biggest term here involved. So let's compare it to the series 5 over 2n squared, because that's what's ultimately going to dictate what this series does as you get bigger. Well, we can take those two constants out of 5 and 2, leaving us the series 1 over n squared. What do we know about that one? That's convergent by p series, p being bigger than 1 there with 2. So now if we can show that this series is always smaller than the one we have, it should also be convergent by comparison test. And it is. By adding these other terms in the denominator, that's going to make the denominator there bigger than the one over here. If you got a bigger number in the denominator, that's going to be a smaller number overall. So this, we would say this series is convergent by comparison to p series. So hopefully you had come up with something similar to that. Okay, this next one, we're again testing the series to see if it's convergent or not. So again, we're going to try and look what's going to ultimately kind of win out in this one. Well, the 4n squared is, and the stuff we have in the top here is 2. So we want to compare this one to that stuff. So we're going to compare our series here to the series 10 n squared over n to the 4th. The plus 1's not really going to change anything. Well, here we could simplify that a little bit. Let's pull the constant of 10 out. And then we'd end up with n squared over n to the 4th. Well, we can simplify that to 1 over n squared. This one we know is convergent by p series, because our p here of 2 is bigger than 1. So what about this one over here then? If we can show that that's smaller than the one on the right, it should also be convergent. And it will be, and here's where that plus 1 does come into play. By adding 1 to whatever the denominator number is, it's going to make that denominator slightly bigger than the one over here. So this series is always going to be less than the one on the right. So if this one over here converges, then this one has to converge as well. So we would say convergent by comparison to p series. So there's our solution there. All right, let's have you try another one here. See if you can pause the video and solve this one. All right, let's take a look and see what you have. This one, arctan of n over n, should be pretty close to the series 1 over n. We know that one's divergent by harmonic series, so if we can show that this one over here is bigger, greater than the divergent series, then it definitely should also be divergent. So is that going to be? Well, if that numerator ends up being always bigger than 1, it should be bigger because if arctan, the value of that's bigger than 1, this fraction on the left is bigger than the one on the right. Well, let's check that out. What does the graph of arctan look like? So if you graph out inverse tangent, make sure you're in radians, your graph looks like this. So if the value is bigger than our starting one here of 1, is that bigger? Well, here's where 1 is. Yes, it looks like it is going to be bigger than value than 1 there, so this should be true. So we would say this one is divergent by comparison to harmonic series. So that would be our solution.